What's up guys, this is LeetCode number of 1 bits, and I'm going to show you 3 different solutions for this problem. We'll start with the most naive solution and work our way to the best. So this question gives you an integer, and you're supposed to count how many ones there are in the binary representation of that integer. For example, this is 11 in binary, and it has 3 ones here. So the most obvious solution is to convert the integer to a binary string and then count the number of ones in that string. And of course, we have to do a return here to return our result. This works, but it's not the most optimal solution because this binary n here is O of n, this count of 1 is O of n, so it's an O of 2n algorithm, which is O of n algorithm, but not the most optimal. How can we do better? We can do our count with a bitwise operator. We know that 11 in binary looks like this, and in order to count this 1 here, all we would have to do is do an and 1, and this would return 1. And so we know that the last digit here is a 1, right? So you can think of this and 1 as doing and 0, 0, 1 like this. So the idea here is to count the very last digit and then shift over and repeat until we hit 0. So first we count this 1, so our count is 1. So now it'll look like this. And then we count again, so now our count is 2. We shift over one more time. Now our n is like this. We do our count again, and okay, well, we see this is not a 1, so we don't add to our count. And we shift over one more time, and we see this is a 1. We add to our count, so our count is 3. Then we shift over one more time, and now we're at 0, and now we're done. We don't do anything, and we return our count of 3. So in terms of our algorithm, we'll have our count, which starts at 0, while n. We'll add to our count n and 1. So again, this will return either 1 or 0 if the last digit is a 1 or 0. Then we'll shift n by 1, and at the end we'll return our count. So this works, and it's a little bit faster than our first solution because we're not converting to a string and then counting. We're just doing the counting immediately. Okay, now how do we improve upon this? This is still an O of n algorithm where n is the number of significant digits in the integer. We can actually get to an algorithm that's O of count, where count is the number of ones. And so what we can do is we can subtract 1 from our 11. So now it'll be 10, and this is the binary representation of 10. And then we simply just do an and of them, right? So what will our and give us? 1 and 1 is 1, 0 and 0 is 0, 1 and 1 is 1, 1 and 0 is 0. So this is the and operation. Then we do it again. So now we say this 10 and 9. So 9 in binary is this. And so we just simply do another and again. So now this value is 8. And we do it one more time. And so it's going to be 8 minus 1, which is 7. And the binary representation of 7 is this. And we do our and one more time. And this time we'll get all zeros. So you can see that the count here is just the number of times we did the and. We did it once here, and once here. That's what we're going to return. We're going to return 3, the number of times we did that operation. So our count is 0, and we'll have our while n loop, and we'll just do count plus equals 1, and now we'll reset n. So n equals n and n minus 1. We can say n and equals n minus 1. And then at the end, we return count. And there we go. So we have our best answer here, and let's submit it. And there we go. So how does this algorithm work? If you look at what it's doing, you can see that first, it's basically removing this 1 from here, right? Because after the operation, we get this. Then it's removing this 1, because after the operation we get this, and then it removes this 1. So it's kind of a neat little way to continuously get rid of the most significant one by one. And so instead of checking every single bit, we just check the most significant one. And yeah, that's all there is to it. So if you found this helpful, please give a like and a subscribe because it really helps the YouTube algorithm, and comment down below with what problem you'd like to see next. See you next time.